السلام عليكم ورحمة الله وبركاته. معكم عبد الرحمن الدلبحي، أنا ريجنال سيلز مانجر في شركة LogRhythm. معي أيضا اليوم زميلي مصطفى سليمان. He's a regional sales engineer for LogRhythm. Today we are going to talk about the MITRE frameworks and how LogRhythm is incorporating the MITRE framework into our solution. To start with this, we'll start with the agenda. We'll talk about what is the MITRE framework. Then we're going to talk about why MITRE framework is essential for your security operations center. Then we're going to talk about a real life example of ABT 29. And by the end of this presentation, we're going to share with you also some reference links, and we also will be able to take questions and answer them. So MITRE framework. So the problem for this, the problem that we are seeing today in many of the stocks is how effective is our defenses. We are investing a lot into cyber security solutions, but we don't have a way to measure the effectiveness of those security controls. Second problem that we are seeing is, can we detect the latest ABT? If today we see a new ABT group, whether it's ABT 29 or ABT 32, are we 100% confident that we are able to detect those advanced persistent threat? The third challenge that we are seeing is, what is the quality of the data we are being collected into our infrastructure? We are collecting a lot of information into our infrastructure, but is this data really valuable for our security operations center, or it is just adding an extra burden into your security operations center staff? The fourth one is, where is the gap? This is a very important question that a lot of organizations need to answer. Where is the gap? Are we missing into our processes? Are we missing into our solutions, whether it's an endpoint or if it's an email security solution? Where is the gap that is allowing the attackers to infiltrate our networks? So before we talk about MITRE and we define MITRE, we'll talk about what is not the MITRE framework. First of all, the MITRE framework, it is not a replacement for your security best practice. Whether this is the staff education, educate physical security controls, the concepts like the least privilege, password hygiene, zero trust modeling, all of this is not being replaced by the MITRE. So MITRE is not a replacement for your best practices when it comes to the security. MITRE is not a replacement also for the indicator of compromise or signature-based detections solution, for example, like the AV. MITRE is a list of achievable objects, so you cannot deploy the entire MITRE framework. This is not the idea. The idea is you implement what is adequate for your infrastructure from the MITRE framework. And it is not a list of techniques that cover all technology or attack vectors. It's going to have specific attack vectors that is focusing on. And one important thing is that if you don't have a SOC, then MITRE is probably not the best place that you should be focusing on. MITRE is primarily designed for your SOC operation and how we can enhance the SOC operation. So what is MITRE? So MITRE is an American non-profit corporation that take funding from the federal government. MITRE stands for attack. It stands for adversary tactic, technique, and common knowledge that are being used. Attack is globally accessible knowledge, so you can access this knowledge from wherever you are in the world, and it is categorized into pieces which is easy to ingest. And attack is based on real-world attack scenario and real-world observation from the attack that we are seeing. So, for example, we have MITRE framework for ABT 29. We have MITRE framework for ABT 32, and so on. Attack is purposely focused on the adversary and the behavior that they exhibit, the tool that they are using, and the action that they perform. And with this, I would hand over this to my colleague Mostafa, who will be able to take us into an in-depth discussion of the MITRE framework. Mostafa, the mic is yours.
Thank you, Abdulrahman. Hello, everyone. It's my pleasure to be with you today. So, continuing on what my colleague Abdulrahman has mentioned about what is MITRE. So, what is the attack layout? So basically, the MITRE framework is built on tactics and techniques. The tactics, as you can see, is multiple tactics, depends on the stage of the attack, and each tactic is covered by some of the techniques that the adversaries are exploiting in the wild to be able to achieve or gain access to organizations' infrastructure. So back in 2011, there was, by Lockheed Martin, there was a cyber kill chain, which was based on some stages of the attack, starting with recon and ending with maintaining access. And the difference between the cyber kill chain and the MITRE attack framework is that the MITRE is much more detailed than the cyber kill chain, and it's mapping each stage of the stages that we have on the Lockheed Martin cyber kill chain into a specific activity that is done from the adversary perspective. So we have the pre-attack, which is covering how is the attackers or adversaries are doing the reconnaissance and doing the weaponization. And then we have the attack matrix itself, which is covering the different tactics that are being followed by adversaries to gain access to organization, starting with initial access, execution, persistence, privilege escalation, defense evasion, credential access, discovery, lateral movement, collection, exfiltration, and C2 or command and control. So what is a technique? We've covered what is a tactic. We've been through what is a tactic, because a tactic is a collection of techniques. Now let's talk more about a technique to be able to understand from MITRE perspective, what is it? So for an example, we'll take one example of one technique, a new service. So a new service is a technique for attacker to maintain persistence or a system. So every time your server gonna start or the endpoint gonna start, this service gonna automatically start and help the adversary to gain access to your machine without having to infect it again. Because every time this service, for an example, starts upon reboot, it will start a C2 communication with the attacker infrastructure. So this is an example of a technique. What is a group in the attack framework? So there are multiple attacking groups that are currently on the wild: APT 28, APT 29, APT 31, FinSec. There is a lot of different groups, and MITRE is also mapping and learning more about these specific groups and able to understand which tool they are using, what are they focused on. For an example, some attackers are focused into oil and gas. Others are focused into banking sector or financial sector. Others are into defense and government. They are specialized to be able to attack these specific verticals and able to, depends of course on their motivations, be able to gain access to this machine using specific tools and then exfiltrate the specific data that they are required or even cause disruption. Depends on the motives for this specific group or for the operation that they are undertaking. What software is a specific software that might be mapped to one or more attacking group that they are usually is using to conduct specific techniques. So for an example, if we talk about Shopstick is one of the malware families that and have a modular backdoor that is related mainly and used by group 28, and it's actually taking care of those specific techniques: data obfuscation, connection proxy, standard application layer protocol, and remote file copy. and the indicator removal on host, and run DLL32, multiple techniques that is MITRE is mapping to be able to detect at each stage of the attack if this, for an example, software or any other software that is using the same technique is being run in the environment. And this is how MITRE is standing out from other frameworks, because it is focusing on techniques that are being used today in the wild by adversaries. So why MITRE? This is a very important question that we will cover in more depth. So we have a spectrum of attack. We have known attacks and we have unknown attacks. So known attacks are based on a specific indicators of compromise or IOCs, for an example, hashes or specific IP addresses or specific software versions. We have the tactics, techniques, and procedures which we were just covering and discussing a couple of slides ago about specific techniques and tactics that are mapped in MITRE, which is still being used by attacker to gain access. And we have behavior profiling, which is more focused into more of a behavioral modeling to be able to understand what is normal and what is abnormal and flag the abnormal compared to the baseline that you have. And this helps a lot with detecting the unknown threats. So the biggest challenge for an attacker, which we call the pyramid of pain for the attacker from the attacker perspective, is being able to detect their tactic techniques and procedure that they are following in every hack they are doing. Because at the end of the day, attackers repeat themselves. Attacker has to do credential dumping to be able to get credential into the organizations. Attacker has to do lateral movement. They have to move from the initial compromise machine to another machine and then pivot through this machine to a third machine. So they will have to do lateral movement. There are some steps that they have to carry over. They would like to exfiltrate the data that they have collected from the organization. So there are specific techniques that has to be followed in most of the attacks from the adversaries. And that's why when we build our detection and analysis based on this specific techniques and tactics that the attackers are following, it becomes really tough for attackers to avoid detection. So there are mainly 3 steps for a successful analytics for this specific framework. First of all, understanding the technique. We have to understand which technique we are trying to detect and try to understand how this technique works whenever it is used by adversary. And then emulate that specific technique into the second step. And there are a couple of open source tools like Atomic Red Team and Caldera that you can use into your environment to emulate a specific technique and see what artifacts and what logs it leaves into your environment, and start developing specific use case or detection rules to be able to detect if this specific attack was really run into your environment. And then keep on fine-tuning on the third step and narrow down the false positive and try to tune it out. And once deployed, you have to keep monitoring it in case of any new false positive or of actual attack happen in place in the environment. So this is a sample of how LogRhythm is mapping the MITRE techniques and what are the log sources that are recommended by LogRhythm to be able to detect this specific technique. So a lot of customers ask, which techniques shall I start with? And I always give them the answer, it depends on which industry you're working with and which attack group might be interested into accessing your environment or getting access to your systems or the data that you have in your applications, business applications. So for an example, for the energy, the top techniques that are used is PowerShell, service execution, and running scripts into the environment. When it goes to communication, we can see that it's also intersecting with the same three techniques that we have mentioned in the energy, which is sector, which is PowerShell, service execution, and scripting. And if we go transportation and aviation as well, it's the same three techniques. So I always start prioritizing by the most common techniques that are being used in this specific vertical, plus the common techniques for the most common attacking group that are focused into this region and this specific vertical. Another important point or a pillar that MITRE ATT&CK helps the customers a lot with measuring their defenses. So the MITRE is simply built on the validation through regular assessment against the tactics that are being used in the wild, and threat hunting and breach detection and incident response procedure against the latest techniques that are being used. So we have in the organization the red team, which is identifying the attack technique that they are willing to test after we do the prioritization in the previous step, and then they start emulating that specific scenario. Then we go to the blue team, which is detect and respond to this specific incident using the SOC-defined playbooks and runbooks. And in case there are no detection rule is built for this specific techniques, they will start building one to detect this specific technique. And then we evaluate the performance of both the teams and redefine and improve, which is part of the continuous improvement. So we improve the attack capability with testing other techniques, and we improve the detection capabilities with being able to create more detection rules, start proactive threat hunting exercises and threat hunting methodology that should be in the organization to be able to detect this technique, which is the mix of the red team and blue team, which we call the purple team. So this is an example of atomic red canary, and we are trying to simulate a couple of techniques in one of the machines. By running the atomic red, we are actually emulating exactly what would an attacker do if he would like to exploit that specific technique and take advantage of this machine. Like for an example, running mimikatz to be able to do credential dumping, running bloodhound to download the credential and doing an exfiltration over an alternative protocol, and credential dumping as well to be able to understand what are the credentials that are stored on the memory of this specific machine. And for the detection, this is a sample of the detection rules that are part of LogRhythm MITRE framework that are able to detect different stages of the attack as a part of this specific attack emulation. So we are able to detect when mimikatz is running to do the credential dumping, when the attack emulation is trying to discover all the users on the system to be able to understand the logged on user and what is the privileges that it has on this machine. Whenever it's trying to do a remote file copy, because this is also an indicator on one of the techniques that are very important into any organization, if there is remote file copying, if there are scripts as well running, and PowerShell as well, scripts specifically, because PowerShell is much more powerful than the normal command line scripts, and exfiltration over alternative protocol. So this is a sample of how we can detect different techniques even if they are chained together as a part of one specific attack that is taking advantage of 5 or 6 or 7 different techniques that are part of different tactics. We are able to detect at each stage what's going on and able to put the big picture that when those multiple techniques are being exploited then this is a very high priority alarm that we receive into LogRhythm, and we start to investigate further because this is have higher fidelity. So let's talk about a sample of one of the attack groups, which is APT29, and how LogRhythm is being mapped to this specific techniques that are used by this group. So APT29 is suspected attribution is the Russian government, and the target sectors that are usually attacked by this specific group is Western European government and foreign policy groups and other similar organizations. Mainly, it's focusing into government and foreign policy groups organization. So we can see the associated malware that are being used by this group and the attack vectors that are being used by this specific group. And here we can see the techniques that are being used by this specific group and how it is mapped to the MITRE framework and to the out-of-the-box LogRhythm MITRE framework. And as we can see, we can detect multiple techniques that are being executed by APT29 hacking group. Key takeaways from this is that the MITRE attack uses real life and real world intelligence on the tactic, techniques, and procedure used by APT groups. And it is really a great way to validate and improve the detection capabilities, measure the efficiency of the detection controls that you have into your organization. It's not a replacement for the basic cybersecurity or best practices that you have in place, like firewalls, intrusion detection systems, intrusion prevention systems, sandboxing, antivirus, EDR tools. It's actually complementing it. And it's really important to implement monitoring into endpoint and behavioral analytics and to collect logs from endpoints because it's very important. It's usually the first point of entry for attackers into the organizations using spear phishing and other techniques that are targeting the users. And Linux and Mac systems are usually not taken care of as a part of the organization policy. Usually we see customers not having an antivirus that runs on Linux or runs on Mac, which is providing a gap into your defense in depth strategy that should be in place to be able to detect in case there are also signs of compromise or specific techniques that are being exploited into your environment and those specific systems, whether it's Linux servers or Linux endpoint in case it's used or Mac endpoints. Those are references, and we'll be very happy to have your questions and to answer it as well. And I would like to thank you very much for your time